He's from 7-1. 20 says, find the angle where the tangent is -1. The tangent is -1 here or there, but they don't indicate it here, but we're assuming we want the principal value, and so that has to come out from the fourth and first quadrant, and so we're going to do minus pi over 4. Next one says we want to find the sine inverse of the sine of negative pi 1/10 pi. So if you're doing -1/10 of a pi, so take the whole thing, divide it in 10 pieces, 5 here, 1/10 would be about like this, and the sine of it would be this length. Now find an angle between 0 and between -2 pi over 2 to pi over 2 for the sine, where the sine is that size, and that would be -pi over 10. So these here basically cancel, but got to be careful because they don't always just cancel. And this might be a case where that's true. So now on this one, 45, the tangent of 4 pi over 5. 4 pi over 5, that's a fifth. 4/5, 5/5 is halfway around, so 4/5 is about here. So the tangent would be that to that. However, the tangent inverse, if we're doing the principal value like they want you to do here, you got to get it out of these two quadrants. Well, that angle, 4 pi over 5, is not in that angle. But the one across from it would still have the same tangent ratio. And since this is 4/5 of pi, this must be 1/5, and so this would be -pi over 5. Now the next one here, got a similar situation. So where is -3 pi over 2? -1, 2, 3 halves pi. That's up here. But the tangent has to come between these two quadrants, and so we have to go this way to it, which should be when we find the tangent inverse of that one, we get pi over 2. Now, it says find f inverse, the range of f, domain, and whatever. So what does this look like? So the tangent is a function that goes up like this and down like this. If you multiply by 2, it gets a little steeper. And if we take it down 3, it still looks something like that. And so, and we're going from minus pi over 2 to pi over 2, which is that one there. So what is the range of this function? Well, it goes from -infinity to infinity. So the range is all reals. So the range of f is all reals. And then what's the domain? Well, of the inverse. So now we have to find the inverse. But the domain of the function's inverse is going to be what the range was. It's going to be all reals. Now to find that, we let y equal this. Switch the y and x. Solve for y. Add 3 to both sides. Divide by 2 on both sides. And then take the tangent inverse of both sides. And that will be y, which is going to be f inverse of x. Now, the range of the original is the domain of the inverse. So the range was all real, so the domain is all reals. And this curve now goes this way. Or no, this way. Now it goes to 3. Goes towards the axis. It goes away from. Goes something like this. So it's a reflection over this y equal x line. And the range will be the old domain, which they told us was this. So the range of the inverse is the domain of the original one, which was the interval from minus pi over to open, because there's no equal on there, to pi over 2. Okay. On this one, I think we're supposed to do the same things. So that this is going from, this is shifted sideways, and so that's why they got these halves on there, and it goes from negative pi over 4 to pi over 4. So we're taking the sine curve, and we're shifting it. If you look at the shift, that should be 2 times x plus 1/2, so it's shifting back a half. We're basically doing the regular sine curve. The period is changing from 2 pi to pi because of the 2. And they want us to take from negative pi over 4, pi, half a pi, quarter pi. So they want to take this portion of it, but shifted back pi over 4, or half. So it's somewhere in here. So our range to this would be from minus 3, the amplitude is 3, to 3. The range on this function, this is the domain of the function. The range of the function would be from negative 3, actually including 2, 3. So, and this would be the range of the inverse, and this would be the domain of the inverse. And the inverse would be found by replacing f of x with y. And then we would switch the y and the x. Solve for y, divide by 3. And then take the sine inverse. And that would leave us 2y plus 1. So then we'd subtract 1 and divide by 2. So we'd get y equals sine inverse of x over 3 minus 1 divided by 2. So that'd be the f inverse function. Or you could put a half here minus a half, and that would work also. But the domain and range just get switched. And now 70, I think, says solve this. So we would divide both sides by negative 6, and we'd get the sine inverse of 3x is negative pi over 6. So this says what angle, and this is an equation, so it could be lots of solutions. What angle has a sine of 3x? Well, that angle they're telling me is pi over 6. So if I take the sine of both sides, sine of negative pi over 6. Here, the sine is negative 1/2. So 3x has to be negative 1/2. Sine of negative pi over 6 is negative 1/2. And so then I divide by 3 and I get x equals negative 1/6. Multiplying by a third. It's probably easier to see that. Okay. And finally, they say the amount of daylight in Houston, which is at this latitude. We're going to put that in there. And this, the sun is this elevation, or this elevation, summer, vernal equinox, in July 4th. And so we're just going to put those numbers in for I. And since this is pi and cosine inverse, we're probably supposed to do this in radians, but these angles need to be in degrees. So this is kind of a spend some time switching modes on your calculator. So you would start off by doing the tangent of 23, so I'll put my mode in degrees. And so I got to do the tangent of 23.5 times the tangent of 29 degrees plus 45/60ths of a degree, or 29.75. That gives me that number. Now I'm supposed to do the cosine inverse of this number, but now I need the mode to be in radians. So now I got to do cosine inverse of that answer, and then divide that by pi. And then do 24 parenthesis 1 minus that answer. And we get, for the first one here, summer solstice, 13.9 hours of daylight. And then we would go through the same process again. I could go back to this answer up here. There's, except now I have to go back and replace not 23 but 0 in here. And the tangent of 0 is 0. So 0 times that, so I have cosine of 0. And cosine is 0 at pi over 2. So I'd have pi over 2 divided by pi, which is 1/2. 1 minus a half is a half of 24 is 12. So this one's going to be 12, since 0 makes tangent be 0. So this one answer would be 12 hours of daylight. So we went from 13.91. Now we'll do July 4th. And so now I need to put in the inclination of the sun is not 23.5, but 22 plus 40, insert 8, divided by 60. Oh, don't need the extra parenthesis there. So that would be the inside part here if my mode is in degrees. So that's what this is. Then I got to divide that by pi. Oh, not yet. Oop, go back to that one. I got this. I gotta take the cosine inverse, but I need to be in radians. Mode, radians. I forgot to take the cosine inverse. Now I got to take the cosine inverse of that last answer, and then divide that by pi, and then subtract it from 1 and take it times 24. So 24 parenthesis 1 minus that answer, and I get 13.85 hours of sunlight on July 4th. Okay?